Good morning, everyone, and happy Friday. We have less than 2 weeks of school left, so we are getting there. This is lesson 107 we're going to be talking about today. So after this, we will have 3 more lessons that we're going to do together. We'll have a short quiz over just the concepts from 106 through 110, and then we'll talk more about what the last week is going to look like for us. But for today, let's go ahead and proceed with lesson 107. So today we're going to be talking about slopes. What is a slope? Well, the first thing I want to do, I want to start off with a little bit of an example here. I've got a coordinate plane, and I want to focus just on the first quadrant here. And I want us to remember that when we graph something, we're always graphing a relationship between two of something. In this case, we're going to be graphing the relationship between feet and yards. So if I could just put some numbers here real quickly, I would know to mark that 1 yard is 3 feet, 2 yards is 6 feet, and 3 yards is 9 feet. And I would graph that line, and it would look something like that. Okay, let's keep that in mind now. Let's go over here. I want to do the same relationship comparison, except this time I want to put the number of yards on my y-axis and my number of feet on my x-axis. So let me go ahead and fill in a few numbers here. And I know that 3 feet is 1 yard, 6 feet is 2 yards, and 9 feet is 3 yards. So I've just plotted some points to show a relationship between those two different measurements. And I'm going to connect those. Okay, now I want to see these side by side. I've compared 2 of the same exact measurements in each one of those graphs. Oh, ignore that these are coming out of certain lessons. I just had this one, like right here. Ignore that. I just had these in my Google Drive, so I pulled these over so I would have something to use for this activity. But anyway, so we're looking at these side by side, and we notice that their slant is much different, even though we're comparing feet to yards in both of those graphs. Okay, we notice that the one over here is much steeper than the one on the right. Okay, and I want to just let you know that what we're talking about here, when we talk about the steepness of a line, we're talking about the slant, which is known in math as the slope. So let's go back to our notes, and we're going to fill in these blanks up here. The slant of a graph of a function is called the slope. Okay, we also can assign a number to a slope to indicate how steep it is and which direction it slants in. So if it slants in an upward direction, you're going to have a positive numerical value on that slope. If it slants in a downward position, you're going to have a negative numerical value for your slope. If it's a horizontal slope, as you can see, I drew them here for you so that you would remember that horizontal is left to right. And if you think about that, if you're laying on the floor and you're not standing up, you're not slanted, you're not leaning against a wall, you're just laying flat on the floor, there's no slope to that. You're not slanted at all. You're just horizontally laid out. So that has a 0 slope. And a vertical slope is actually considered undetermined. We don't know the numerical value of that. Undetermined. Okay? It's not 0 because it's not laying flat. It is standing up, but it is an undetermined slope, so just keep that in mind. All right, so let's go look at example 1 together here. We're going to state whether the slope of each one of these lines is positive, negative, 0, or cannot be determined. Here's how you do this. Now you notice each line here, mine's a little blurry because as I make this a little bit bigger, it's hard to see some things, but you have yours in front of you. There's the lines. That one didn't come out so good. Let's fix that one. Okay, so I've just made them a little bit darker in blue. All right, so here's how you work this. So you cast your eyes at the left side of the line, and you follow it left to right. That line is heading in a positive direction. So the slope of that line, the numerical value, is going to end up being positive. Okay, the one on B, we said if it's a horizontal slope, it's 0. There is no slant to that line in B. Letter C, again, we start at the left side. There's your eyeball. We follow this line left to right. It's heading in a downward motion, and so the slope on that is going to end up being negative. And we're going to see how these play out in just a little bit. And letter D is a vertical line, and we set up above that a vertical line, its slope is undetermined. It cannot be determined, undetermined. So go ahead and make sure you fill all of those in. Now I'm going to talk to you a little bit about the numerical value of a slope. I have another sheet here that I need to pull up for us. Oops, that's not it. Oh, okay. I need to go get it from Google Drive. Sorry, guys. What did I do with that? I had it over here a moment ago. Oh, here it is. There we go. Okay, awesome. All right. These came right out of your book. And I want to just talk to you about how to determine the numerical value of a slope. In other words, let's identify what is the steepness of this line. Okay, so you notice you have this line plotted on your coordinate plane. 3 of the points are circled, and those are very significant when you're talking about identifying the slope of a line, because those 3 dots that they put on here, those 3 points, are at a point of intersection on the graph. So what do I mean by that? Well, let me expand this just a little bit. So kind of notice here, if I can keep this up, notice that this point right here is not at the point of intersection. If that was at the point of intersection, it would be right here. Okay, so you're looking for points on your line that are hitting at an intersection of one of those little tiny squares there. So in other words, if I could draw that for you, I would say it's right there. Right where those lines on the graph intersect. Okay, so please make sure you understand when I say point of intersection, because we're going to be looking for those in just a little bit. That's very significant in this activity when you're looking to find the value of a slope, numerical value of a slope. Okay, so I'm going to pick 2. Doesn't matter which 2 I pick, but I'm going to pick the ones that are closest together, because that'll give me, it'll give me what I'm looking for. Any of these actually I could actually connect any of these that I wanted to. I could connect this one to this one, but I'm going to pick the ones that are closest together. And I think a little bit later I can show you why. But what I'm going to do is I'm going to make a right triangle out of these 2 here. You can see it's a right triangle. Okay, and I'm going to use some terms that are very significant when we're talking about slope. Okay, now I am going to start right here, and I am going to run from that yellow dot to that yellow dot. Okay, so I just ran, or we're going to run 2 steps in a positive direction. From that point, I'm going to rise to the next point. And how many units was that? 1, 2, 3 in a positive direction. That was rising, positive 3. Okay, now I'm going to move over to this one, and we're going to look at how we can figure out the slope. And I haven't actually finished that problem. I want to actually go ahead and get these built in first, and then from there we'll talk about how to actually numerically write the slope. Okay, so on this one, you notice again, they have marked points of intersection. Okay, I'm only interested in 2, so I'm going to grab 2. I'm going to grab this one and this one. It doesn't matter which 2 I pick, but I'm going to choose those. And I am going to build myself my right triangle. And then I'm going to write here my rise and my run. Okay, so I am I am running from this point to this point in a positive direction. How many steps? 2. So I've gone 2 steps in a positive direction when I was running. Now I'm going to rise. Now here's the interesting thing, because when you think of rise, you think, oh, well, that means up. But rise in a slope activity, when we're rising, it can be in a positive or a negative direction. Rise means either way. It just means that it's up and down. So in this case, I'm rising from here to here, 1 unit, negative. Okay, so I went down. It's a negative direction, 1 step. So we call that rise a -1. Now, the interesting thing that I want you to remember is that the slope of a line equals rise over run. Okay, and actually in your notes, this would be a good time for me to point out to you, over here in example 2, I want you to highlight that or circle it or something, but do something to make it stand out. All right, let me go back to where I was and let's talk this through. Because now that I know, so the slope of a line is the ratio of its rise to its run, and we write it as rise over run. That's the slope. Okay, and that's a term that you're gonna remember for the rest of your algebra career. Okay, so rise over run. So let's look at this graph over here. If I'm gonna write rise over run for this graph, we said the rise was +3 and the run was +2. So the ratio is 3 to 2. So my slope is 3 over 2. That's the slope of this line. Now let's go look at this one. We're still going to use rise over run because that's what we always use for slope. We said that the rise was -1 and the run was +2. So we know if you have a negative number in the ratio, just one negative makes the whole thing negative. So the slope here is -1/2. Okay? Now, let me just point out a couple more things to you, and then we're going to do example 2 together. You know what? I'm going to go here, because I already have some built. Okay, so a line whose rise over run well, actually, let me build this in here. Let's just say, I'm going to erase that. I'm going to state this a different way. If my line was plotted like so, and by the way, the function for that, the equation, would be y equals x. The slope of this is 1. And why is that? Because a line whose rise and run have equal values will have a slope of 1. Now, if I were to draw this triangle, I would see I have a rise of 1, right? And a run of 1, positive on both of those. Okay, and it continues on. You can see that. It's going to be +1 all the way up. Okay, so the slope is going to be a 1. That is for those that the rise and the run have equal values. Okay, and I could write that out. If it's rise over run, let's do that. If it's rise over 1, it's 1 over 1, which is equal to 1. A line whose rise has opposite values of its run has a slope of -1. So for example, if that was your equation and this was your line, and I connected these, if I check out how my slope's going to look, I am running 1, so rise over run. The run is -1, and the rise is +1. You see that? So you just keep running and rising. Oh, look how that did. Running and rising, running and rising, running and rising. Okay, so it turns out that the rise over the run is +1 over -1, so the slope is actually -1 on a line like that. So that's a line whose rise has an opposite value of its run. The slope is going to be -1. Okay, let's go to example 2 in our notes. All right, here we go. So we want to find the slope of this line. So we want to identify 2 points that are landing on a point of intersection, and I happen to see one is right here, and I see one right here. I do see others. I see one way up here, and I see one way down here. But I'm going to pick the 2 that are closest together to help us out here. Okay, and I'm going to connect these. I'm going to make my right triangle. And I notice that I'm rising here. Whoops, I don't want to say rising, I want to say rise. Figure out what our rise is. We're rising from here up to here, 2 steps in a positive direction. And from that point to this point, we are running in a positive direction 3 steps. Okay, so let's go off to the right and write rise over run and fill in what they are. We said the rise is +2 and the run is +3, which is basically 2/3. And that is the slope of that line. And I just want to point out one more thing. I don't know how well I can blow this up without our vision getting really blurry, but we can check for a correct calculation of a slope. If I could just zoom in on like one, let me use a different color here. I'm going to take this green. I'm going to just focus on this square right here. If I could just zoom that in really, really big, you could see it. Okay, so I want you just to focus. I'm going to erase that because I need you to see, well, I guess I can leave it. Okay, see where the line is going through that? Right here? That point is at about 2/3 of the way up this line. So if you can zoom in on one of those squares where you have between your 2 points, well, between this point and this point, you can see that the incline hits at about 2/3 of the way up. And that's just a kind of a way to kind of evaluate if you've done a good measurement here. Okay, so that, my friends, is learning about the slope. Something strange is going on here. I don't know what that little circle is, and I can't get it off. Here we go. We'll come back now and be gone. There we go. Perfect. And I didn't want to do that. I think I'm getting tired. It's been a long day, guys. Anyway, I'll fix these notes before I actually post them. And actually, you won't need those because I'm going to post my other notes. Okay, so I think we are all set. Oh, yes, you will need those. But they're posted on Google Classroom. Yeah, sorry, guys. I'm going back and forth here thinking about too many things. Okay, so that's basically how you find the slope. You understand that a slope is the slant. You can see how we determine the numerical value that we're going to assign to each slope. We've learned 4 different directions of slopes and what kind of a result, numerical result they will have, whether it's positive, a 0, a negative, or undetermined. So that is that. I also included an activity sheet there for you. I think this lesson has gone a little bit long, so I'm going to skip that, and maybe we'll go over that another time. So I'm going to go ahead and end the lesson there. Go ahead and get as much done as you can before our Zoom call. Bring questions with you, and we'll go over what you need help with. All right, guys, thanks for watching.